Assalamu alaikum everyone. Today we will study about measurements and devices lab. So in this lab we have 10 experiments. You can see here: digital laser tachometer, cable locator, thermohygrometer, sound level meter, clamp multimeter, EMF meter, noise dose meter, Megger, LCR meter, analog multimeter. So these many experiments with practical experience we will study in this lab. So one by one we will start. The first is digital laser tachometer. So in this digital laser tachometer, first I will tell the brief theory, what its name, how it comes, and how it is, how to measure how to use the device, everything I will tell. Now, our aim is to measure the speed of rotating object using digital laser phototachometer. So, before going to practical, first we will study what is digital laser tachometer. Now, the digital laser tachometer. So, this tacho means here a Greek word which means speed. So meter, which is used for measuring something. So tachometer means speed meter, it is there. So where the laser comes. Okay, before laser, first we will study what is digital. So digital is nothing but a numbering 1, 2, 3, it will come. Another device is called analog meter, like in a watch. So in a watch you can see this is the analog, there where the pointer will move one by one. So that is called analog. In this digital also available in my watch. See, 1 hour 52 minutes 40 seconds. So this is digital. So analog is when there is a pointer. So if you see the old model of the cars or any meters, there is a speed meter which is analog, where the pointer move from 0 speed to 120 kilometers, 100 kilometers. So it will show the reading, how much fast you are driving the car. Here in digital it will show the number. Means if you are driving the car for, let us take 60 kilometers per hour, it will show the number 60 kmph, kilometers per hour. So this is digital. Now coming to the laser. So laser means we see the device here. This is the device. Practically I will show next. Here only pictorial I am showing. Here when you press this number 1 button continuously, a laser beam will come out continuously. This will hit the rotating object. So by using this laser light we are measuring the speed. How we will come into the practical case, that is, for that what we need: laser phototachometer, the device, and reflecting mark and rotating object. So the reflecting mark we need to put on a rotating object. Reflecting mark is nothing but radium sticker you can use. So that reflecting mark, what it will do? So when a laser beam is coming out from the device, it will hit the reflecting mark. Then that reflecting mark will reflect that laser beam back to the device. Maybe back, it may be device or somewhere, but it reflects back. When it reflects back, the device have one sensor beside to the laser beam projector. So that sensor will count that laser beam as 1. Now in next rotation of the object, again that laser beam hits to that reflecting mark, and that reflecting laser will reflect back to the sensor. So that sensor will count as 2. So like this, in every rotation the laser beam hit the reflecting mark and come back, and it will absorb in the sensor and it will count continuously. So this is what we are doing in the digital laser tachometer. So in this tachometer we have some parts. So that laser I will show you. Now, if you see this laser tachometer, it is there in you. So this is the actual digital laser tachometer. In this, if you press continuously, a light will come out. You can see on the screen there is a light continuously. If you press this button, a light will come out. It is showing on the screen. So when you see inside, we have two bulbs, means two items inside. It is there. So one is called projecting laser, another one is called absorber when the laser beam reflect back. So that it is meant to be counted 1, 2, 3 for the measuring speed. So in this meter we have two types of speeds. One is RPM and one is RPS. What is RPM? RPM is rotations per minute and RPS is rotations per second. So the equation you can find with minutes and seconds. That is 60 is the difference between the rotations per minute and rotations per second. This equation you can submit in your assignment that I will upload in the blackboard. Don't worry. Now, how to take the reading? Just I will rotate this camera for the practical purposes. So the precautions for this is this laser beam should not hit our eyes. So be careful that one. Okay everyone, so now we see the practical session of digital laser tachometer. So in my hand there is a digital laser tachometer. I already explained how to use it. We have to press continuously this button, then a laser beam will come out. You can see on here there is a laser beam is coming out. Now we have to measure here. There it will show RPM. It will show RPM, rotations per minute. How to use this one? So another thing I told you, just see the reflecting mark on it. Here there is a reflecting mark. On this rotating object. If I on this, it will start rotating. Now let us measure this one. So what we are doing, just we are continuously pressing this so that a zero reading first it will show. It will show the zero reading. Now I just put this laser mark on the rotating object. I will show here. Laser mark on rotating object. Just see. Now there is a memory option also. There is a memory option. This button we have to press when it is reading, then it will store the instant value at the time of press. So just use this and so continuously press, use this button. Now see the reading. .4864. The reading is 4864. So like this we have to take the measuring. We have to measure the rotating object by using the digital laser tachometer. So I hope you understand well. So I will once again repeat that we need a reflecting mark on the rotating object here, and we have to continuously press this button so that a zero reading will come and a laser light will come out. Now when you are pressing, I am keeping this here and the reading is coming out 4500, 4800, because it's fluctuating based on the voltage and motor condition. Now I will take the memory, means I will store this instant reading. Next we will stop the machine and see the value. You can see the value here, 5347. So like this we have to take the reading of the rotating objects by using digital laser tachometer.